We'll start now. See, this is the anomalous expansion of water that we want to discuss, right? It's a small topic. Anomalous expansion of water is the behavior. It is the behavior of water. Example, like suppose the ice is at this 0 degree centigrade, -1, -2, okay, -3. 4, like this will keep on going. Here it is 1, 2, 3, 4, 5, keep on going. Now what happens is there is a ice, there is some ice. Now it is at -10 degrees centigrade. So what will happen? Now I start supplying heat to that. So the volume of the liquid will start melting, right? It will start melting. Now what will happen at 0 degrees centigrade, from 0 degrees centigrade to 4 degrees centigrade, the volume will decrease. Okay. So from as it is melting, volume will increase. Here from 0 to 4 it will keep on decreasing. Again it starts increasing. Okay, again it starts increasing. Same way. Now when we are cooling the liquid, so it decreases. Again, from here to here, the volume increases. Again, it is not decreasing. Understood? Why? This is said to be the anomalous expansion of water. Means water has a different behavior from 0 to 4. Why 4? Because at 4 degrees centigrade, water has the density of 4 degrees centigrade. The density of water is maximum. The density of water or H2O is maximum. No. Density of water is maximum at 4 degrees centigrade. Is that clear? If you there's a graph also. In the graph, I think there are two graphs here which are given in the book. Okay. One is it is given in this way, something like this. Then you can get that. So there is a graph. Okay. Now in that graph, it tells see here. There are two graphs, temperature versus volume and temperature versus density. This is temperature versus in degrees centigrade versus volume. Volume is 1 kg of water, 10 to the power of -3 meters. Now what happens here? Yeah, 10 to the power of -3. Again. Yeah, -3 meter cube. Yeah, -3 meter cube. So at 1, it is becoming 1 at what? See, it decreases at 4 degrees centigrade. This is 4 degrees centigrade, and it increases. Suppose. Second one is what? Suppose. Second one is temperature versus density. This is temperature, degree centigrade, and density. kg per liter. Okay, so what will happen now? At 4 degrees centigrade, the density of water is maximum. Density of water is maximum at 4 degrees centigrade, and volume is minimum at when I say density is maximum, volume is minimum. See, what is the formula for density? Mass by volume. Okay, mass by volume. As volume increases, density decreases. Is that clear? So at 4 degrees centigrade, volume is minimum and density is maximum. So once again, I take ice which is at -10 degrees centigrade. I heat it. So what happens? It reaches 4 degrees centigrade. 4 degrees centigrade melting takes place. Okay, means ice converts to water. Sorry, 0 degrees. What it is? Oh, sorry. So 0 degrees centigrade starts melting. Keeps on it melts. Water, ice melts at 4 degrees centigrade. Then from 0 to 4, what is happening? Volume is instead of increasing, it is decreasing, and again it decreases. Further, at the same time, if you come the other direction, like when we have water at 20 degrees centigrade and we keep on cooling it at 4 degrees centigrade, what happens? It keeps on rising, and again from 0 it decreases. Is that clear? This different behavior of water is known as anomalous expansion of water. So that is the reason why we say we should not fill the bottles completely with the water. Like suppose you want to keep some water in the freezer, like you want to make it ice. So or want to make some ice in the freezer. So don't keep it completely full. Like what happens in the bottle also, you have to leave some space. If you don't leave the space, what will happen? The bottle will bulge. The volume will increase. Understood now? There is no space to rise. So the volume will increase. Even you might have seen if you keep the Coke can in the freezer, Coke can or something in, so it will, the shape of the Coke will change, right? If it increases further, it will burst in the, in the freezer itself. If you can experience this, and not only this, take a bottle completely full and then you put it in the freezer, you see it will break. If it is a metal one, the shape will change. Understood now? So this is one example. Second example is anomalous expansion. So one more example. Like suppose if you go to Antarctica or Russia now, where the temperature is very low. Okay, so there is a water here. There is water here. There is a small pond. Because of the cool breeze. No, cool breeze is very dangerous. So that is why your parents say to wear woolen clothes or cover your ears or nose, especially when there is a cool breeze. Is it not? But we are all heroes. Okay. We don't want. We're just like okay, nothing will happen. Now, next day you will fall sick. Like the time starts. Yeah, is it not? Then online examination request will come. Is it not? That the thing happens. So here, see this. Like suppose there is some you go to Antarctica. Okay, there is nothing. There's no. You have to carry your own food. You go to Antarctica. Now suppose you have some fishes and you can store it, but you can't cook it, right? So now, suppose the cool breeze makes suppose there is some water here in the pond, and what will happen because of the cool breeze, the surface of the water will become ice, thin ice. You might have seen in the movies also, the thin ice will be there, there is a water inside. Yeah, because of the cool breeze, the surface of the water will become ice. And this is at what degree centigrade? This is 0 degree centigrade. This is 1 degree, 2 degree, 3 degree, and 4 degree. So what will happen? The fishes are alive. The fishes they keep the fishes alive in this. They take the fish from the ocean or from the sea and they put it here in the pond. So what will happen? The fishes are alive. Whenever you want to cook, want to have the food, they just take it out and fry it and eat. Okay. Yeah. See what we have. So what is, because the density of water is maximum at 4 degrees centigrade, right? Density of water is maximum at 4 degrees centigrade. So ice, the surface of the water will become ice. Listen. The surface of the water will become ice, but as you go down, the temperature is becoming maximum 4 degrees centigrade. So the fishes are alive at 4 degrees centigrade. Understood now? So that is how the marine animals or plants are surviving in the Antarctica or Russia or cold countries. Is that clear? Is that clear? So there are so many, other than that, there are so many examples of anomalous expansion. One example I have given the water what we keep in the freezer, and the second is this example. You can even keep, suppose you keep a one glass of water completely full to the brim. Keep it in the freezer and see the volume will slowly increase. It becomes concave or something like that. Shape will become like. You can observe this. This is because of the and anomalous. One more example is iceberg. Iceberg? Iceberg, what happened? 90% of the iceberg ice is in the water. Only 10% you can see, the tip you can see. Yeah? Titanic. Yeah. So it is like this. You can see only this much. This much part you can see. 90% is inside the water. Okay. So what will happen? Very small, you can see the small piece like this on the surface of the water for iceberg. Okay. Why ice can float on the surface of the water? That you know why? Because the density of ice is lesser than the water. Density of ice is lesser than the water. That is the reason it floats on the surface of the water. Clear? Understood? Again, this is also one of the example of anomalous expansion of water. Clear? So there are so many examples. Okay. So we will go ahead now. This was the missing topic from thermal properties of matter. Clear? Is that clear? The notes for 3 lessons I have already sent. You just forward it to everyone. Now we will go with the next one. Is there any doubt in this one? Any doubt in this one? What was so serious discussion? What happened? Is everything fine? Now. Oh, sorry. Okay, right. Not how? Ah, then I can get straight like this. Done? Now, that's it, right? Want me to draw the point of That's not required. If you want, you can learn. This works upon this principle. I mean, height, right? In the height, G with height. So gather no. We are from this is converted to this one using this formula. Using that formula, it has been converted. Understood? Now, girls, listen. Next is oscillations. Oh, fine. Okay. Now, so we will go ahead with oscillations. Okay. So oscillations, very simple chapter. See, this is the third module in third module. There are total 3 modules. I told you there are total 6 modules. 3 modules in the 3 branches, or 3 modules in grade 11, 3 modules in grade 12. So first module was mechanics. Mechanics means until fluid mechanics was mechanics. Thermal property, thermodynamics, thermal properties, and kinetic theory comes under the second part, thermodynamics. Third part is waves and oscillations. So this is oscillations. After this lesson comes waves. Okay, small lesson, very small lesson. Oscillations. So oscillations. Yes, to and fro motion. There are total 4 types of motion. What are they? One is linear motion, circular motion, rotating motion, oscillatory motion. Okay. Once again, linear motion, circular motion, rotating motion, oscillatory motion. Linear motion means translatory motion means what? Straight. When the body is moving in a straight line, then we say it is a linear motion. What is circular motion? When the body moves about a fixed point, it's known as circular motion. Moon revolves around the earth. Earth is the center of the point. Same way, sun is at the center, earth revolves around it, right? So there is circular motion. Next is what? Rotatory motion. Means about the axis. When the body moves about the axis. Okay. Top. What is that? Top. Top is example. Beyblade top. Those are the examples of rotatory motion. Oscillatory motion. To and fro motion. To and fro motion is known as oscillatory motion. There's a difference between oscillatory motion and vibratory motion. What is that? If the oscillations are small, maybe less than 10, we say oscillatory motion. Oscillatory motion, like pendulum of the clock. Yeah, we say oscillatory motion. But if it is more than 10, we say vibratory motion. Okay, more than 10 are known as vibratory motion. Clear? So now next one is what? SHM. SHM means what? Simple harmonic motion. That we will discuss in this lesson. Next is the equation of displacement, equation of velocity. Like we had displacement, velocity, acceleration, right? In first lesson, in the second lesson. Displacement, velocity, acceleration. Yeah, we studied, right? What is velocity? Rate of change of displacement. And what is acceleration? What is acceleration?
Rate of change of velocity.
Where rate of change of velocity acceleration. Yeah. Today, no, nothing. New. Today's now. That's good. So there was one, when I was like in last month, there was one class that every day you used to come one day here, like this one. No, there is. Okay, so he's bored with one hairstyle. Okay, velocity acceleration. Next is energy of the. We will discuss about energy of SHM and some system executing SHM. Spring mass system we will discuss. Then we will discuss simple pendulum. Damped oscillations is removed from the syllabus. Damped oscillations, natural vibrations, resonance, anyways, I will teach. It's not a big topic.
No, sir. No, it's really completed. No need. It's already reviewed.
Oh. Okay. So here.
Last is not there.
Yeah, now periodic motion. Periodic motion. Yeah, no, you can. I will send this. I have already sent it.
Sir, you don't write from home, you write from here.
Yeah, just listen. Listen, after later on, copy, no? Tiba. No. Now here, we have periodic motion. What is periodic motion? A motion which repeats itself after regular interval of time. A motion which repeats itself of what desperate to talk. What happened? Anything important? You might forget. Yeah. Now, a motion which repeats itself after regular intervals of time is known as periodic motion. Can I say rotation of moon is a periodic motion?
Yes.
Rotation of moon is periodic motion?
Yes.
No. Now, periodic motion. So, now here, revolution of Earth around the sun, motion of a swing, pendulum. So these are all the periodic motion. Swing. Maybe you might not know. Swing. You know the swing, right? When you are, even now also you like to say.
Yes.
Okay. Someone is showing you from that.
Sir, we can do after.
Okay. You can write it. Right. Only five is that. Earlier no sweet, more sweet than spice. Now less sweet, more spice.
No,
Okay, let me go ahead now. Okay, now we will go ahead. Yeah, oscillatory, oscillatory separately. Oscillation less of less. For low values, we say oscillatory. For high values, we say vibratory. Now, it is the oscillating oscillating this is so it is that portion which the body moves to and go back and forth repeatedly. They definitely interrupt. Even oscillating motion is periodic motion, but every periodic motion need not be oscillating. See, every periodic motion need not be a oscillating motion. Oscillating motion is oscillating motion is periodic motion. Oscillating motion is periodic motion, but not all oscillating motions are periodic. Not all oscillating motions are. Listen. Not all oscillating motions are periodic motion. So, can you give me an example for that? A periodic motion is an oscillating motion. Okay, but not all oscillating motions are periodic motion. Swing, simple pattern. Can you say some example where? Can you tell me some example where it is a oscillating motion? So every periodic motion need not be oscillating motion. It should be a periodic motion, should not be oscillating.
What?
See, every oscillatory motion is periodic,
Yes.
but not all periodic motions are oscillating. Periodic motion.
But that's not also. One
Why are you swinging then? Okay, now we'll discuss some definitions. Which are there in chemistry? First is amplitude. Amplitude means maximum displacement of the particle from its mean position. Maximum displacement of the particle from its mean position. See, here. Suppose if I take a wave, so this is the maximum displacement of the particle from its field. Maximum displacement of the particle from its field position. Or if I am going with the oscillating motion, this is the pendulum. So this is the amplitude. Okay. If it is to and fro motion, this is the amplitude. If it is like spring mass system. Okay, if it is here, this is the amplitude, maximum from the mean position. Maximum displacement of the particle from its mean position is said to be amplitude. Is that clear? Next is what? Time period. What is time period? Time taken to complete one oscillation. Time taken to complete one oscillation is said to be time period. What is time period measured in seconds? What is frequency? Number of oscillations made in 1 second is said to be frequency. Number of oscillations made in 1 second is said to be frequency. Next is phase. Okay, one more definition is there. Amplitude, frequency, time period, wavelength. What is wavelength? What is wavelength? Length of, yeah, distance between successive crests or trough is known as wavelength, or length of one wave. Length of one wave is known as wavelength. Wavelength is denoted by lambda. Once again, amplitude, maximum displacement of the particle from its mean position is amplitude. Time period, time taken to complete one oscillation is said to be time period. And amplitude is measured in meters or centimeters. Time period is time taken to complete one oscillation. 1, 2, and 4. Means what? Suppose the bob is here, it goes to this one, again comes to this extreme, again comes to the center. This is one oscillation. Like suppose this is a pendulum here. This is a pendulum here. So suppose it goes, it starts from here, goes to this end, goes to this end. This is one oscillation. Understood now? Or one complete oscillation. Start from one end, goes to the other end. This is one oscillation. Understood now? So time taken to complete one oscillation is said to be what? Time period. Next is frequency. Number of vibrations made in 1 second. How many vibrations they are made in 1 second? This is said to be all frequency. So you can have seen on the tuning fork. How much it is? Some 500 hertz, something. Next, 400 hertz. Okay, it vibrates 400 times in 1 second. But can you see that? Why? Huh? Why you can't see the vibrations of tuning fork? What is the reason, Mahima? Wait, Mahima will say, let you'll allow. Anasha. Used to be very quiet in the class. Suddenly, Mahima is making you talk, huh? No problem, tell. Very fast. Why? So, can't we see that? Our perception of the eye, listen carefully. Perception of the eye is only 16 times. If anything oscillates less than 16 times, our eye can differentiate. There are two things: perception of ear, perception of eye. Perception means, you know that, no? We misunderstand. He says something, she says something, and we misunderstand in some other way, right? That is said to be perception, you know, in English. Yeah, perception. We have perception of vision, perception of hearing. Perception of vision means if anything vibrates less than 16 times, you can interpret. Yeah, it is moving. If it is more than 16 times, it is happening in front of us. More than 16 times, you can't see, you can't differentiate. It's something like happening. So what happens? You know, listen. Like suppose in cinema hall, earlier we used to mount that reels on the projector, but now that system is gone. They used to have reels. Suppose if I want to play a movie in this cinema hall, and there is a projector room. In the projector room, there is a motor, 2 motors. Okay, there are reels, boxes, 3, 4 boxes for one movie. Some 4, 5 reels will be there. They mount that reel on the motor and on the projector, and the projector starts moving. So there are pictures actually. There are so many pictures, multiple pictures. They move on this and like it's happening, like the movie is playing in front of us. Like how many reels? 16 clips. More than 16 means 20 clips in 1 second. So when 20 clips are, the speed of the projector is like that. Like in 20 negatives, you know, negative. Have you seen negative? Negative in the olden days we used to have negative. Now it is not there. Negative used to be there. So 20 negatives will move in 1 second. Then it will be like something happening in front of us. Understood now? So that is the perception of vision. If anything happens if anything is moving more than 20 times or 16 times in 1 second, then it's like something happening in front of us. Understood? Same thing. What is the perception of ear then? What is the perception of ear? Anyone? It is 10. Anything which vibrates, if anything is vibrating like less than 10, you can interpret it. Our ear can interpret. But if it's more than 10, our ear can't interpret. It's like something like continuous sound. So that is why when you strike the tuning fork, like you will hear a buzzing sound. Sound, but not like tin, not like that, right? So it should be like that, right? Oscillatory motion means should be like on off, but it's not like that. It's like continuous sound because it is more than 10 in 1 second. Got it? It's more than 10 in 1 second. Got it now? So we have perception of hearing, perception of seeing, vision, perception of vision and perception. This is there in grade 10, right?
Vision of the sound.
Vision is there. Perception of vision. Okay. Now, yeah, very important concept. Next is the what? Phase. Phase, very important. It describes what this definition we can write, but actual definition which I found out from some other book, not from this book. It describes the state of motion and direction of a particle. It describes phase. It describes the state of motion and direction of a particle. It describes the state of motion and direction of a particle. It describes the state of motion and direction of a particle. Motion and direction of a particle. It describes the state of motion and direction of a particle. It describes the state of motion and direction of a particle. Okay. Now, what happened? What happened? Now you don't want to write anything. No. Okay, so there is one more definition here. Angle made with its initial position. One more definition. If you can understand the concept of phase, great. 12, 2 topics are very simple. Not 2, 3 topics. Alternating current chapter and interference. What is that? Wave optics. It becomes simple for you. Even electromagnetic waves. 3 chapters will become easy if you can understand the concept of phase. Okay. Angle, you can write second definition. Angle made with its initial position is said to be phase. Angle made with its initial position is known as phase. Okay. Now, let me disconnect this and convert this phasor diagram first. I'll explain you the phasor diagram. Then we can do that. Now, so here, see here, phase I wrote, right? Phase is denoted by a symbol phi. See, this is phi. This is phi. This is phi. Yeah. This is psi. Shy. Yeah, shy. Oh, you want me to write shy? Yes, I try. Shy. That's shy. This is sky. So, this is kappa. Sky, pi, sky, and kappa. Okay, now, phase means. Now listen. Next is phasor diagram. Phasor diagram. Listen. Now listen. Girls, stop talking and listen. Now listen. Here, listen. This is it. I want to projection of a wave on a circle. Projection of a wave on a circle.
So that the figure.
Projection of a wave on a circle is said to be phasor diagram. Listen first. Very, very important. Now suppose, now the particle is at O, it is here. Particle is at A, it will be here. Particle is at B, it is here. Particle is at C, it is here. Particle is at D, it is here. Understood now? Means when the particle is moving like this, particle is moving on the circle. Once again, when the particle is moving like this, the particle is moving on the circle. Got it? See, when it is at A, the particle is here. When it is B, particle is here. When the particle is in C, it is here. When it is at D, it is here. When it is at E, it comes back. Understood now? Means projecting a wave on a circle is known as a phasor diagram now. Now when I say this as phi, this angle is phi. Understood now? See, now suppose when I say this is 90 degrees. So when I say this, okay, so when I say this is pi by 2, this is the particle is at B here. This is pi, means what? This is pi by 2. This is pi. This is 3 pi by 2. And the complete circle will become what? 2 pi. Understood now? Is that clear? 2 pi. Understood? So means we are projecting a wave on a circle, that is said to be a phasor diagram. Is that clear? Is it clear this for all of you? Very, very important. Now we have in phase. 3 concepts are there. In phase. In phase means phi is equal to 0 degrees. Means what? There are 2 waves like this. There are 2 waves. Listen carefully. There are 2 waves. One is y1, the other is y2. Okay, this is y1 and this is y2. 2 waves. Angle is how much? 0 degrees in phase. No phase difference. Means what happened? You are watching the movie and you are understanding the movie at the same time. In phase. Yeah? You see, now Kavya is talking to Wafa is also talking. They are understanding each other. In phase, they both are in phase. Here also they are in phase. Okay, clear? They are in phase with each other. Clear? That is angle is 0 degrees now. Yeah? And tune. We said tuning, no? There's a good tuning between both of them. Yeah? They are in phase. Clear? Freya and Radhika also in phase. Clear? Is it not? They are in phase. Understood? Yeah, they are also in phase. She is out of phase. What is out of phase? Let us see. Okay, out of phase. Out of phase means what? Pi is equal to 180 degrees. Pi is 180 degrees. Now listen. Now suppose. Now this is y1. This is y2. Angle is 180 degrees. Listen. Now suppose. Example. Okay. Srinidhi, she goes to her. Okay, she's in a very good mood, and all the classmates have planned for a picnic or some treat or some program outside. She's very happy. She went and she asked her mother, like, I want to go with my friends. No. Yeah, with Freya and Radhika, I want to go outside. So give me some money. Now mother is out. Mother is very angry. So she go sit inside and read. Study. Okay. By mistake. Okay. Okay. So what happens? Your mood goes off, right? Yeah. Mood goes off. That is out of phase. Okay. Out of phase. Understood? Means I am explaining it to make you understand. But the angle between the 2 waves is how much? Angle between both the waves is how much? Yeah, that is out of phase means. Now many things happens out of phase. Okay, yeah, in the life. So one is this is out of phase is about 180 degrees. Understood now? But last one, is constant phase difference. Constant phase difference. Constant phase difference is what? Like there are two waves. This is Y bar. This is Y. Leading or lagging of the leading or lagging of a wave. Leading or lagging of a wave. Examples, the teacher was teaching. Oh, after some time, yeah, I got it now. Yeah, sometimes it happens, right? He taught first time, second time, third time, she got it. Yeah, lagging. Leading or lagging of a wave. That is said to be what? Like when you're talking on the phone also, right? It happens. Like when you're talking on the phone, it sometimes there is a lagging, right? The signal lagging is there. After 1 second, they will say yes. Over 2 seconds, they will say. That is how they hear. There is lagging of sound. Okay, that happens in the networking also. So all these things are used in networking. If you are asking me, sir, where it is used, I say it is in communication. Before I was teaching communication, so all these concepts are used in communication. Okay, clear? Electrical signal. Okay, in electrical signaling system, electromagnetic waves and all that we use this one. Is it clear, all of you? In phase, 0 degrees. Out of phase, 180 degrees. Constant phase difference. Sorry, constant phase difference is how much? Leading or lagging of the angle can be, there can be a angle 60 degrees, 40 degrees, whatever it is. Whatever it is, some angle is there, some angle difference is there every time. That is said to be constant phase difference. So now you plan whether you want to be in phase, out of phase, and constant phase difference. So yeah. Or you want to be out of phase? With whom? With Okay, right off. Okay. Understood this concept. It's a difficult concept. I don't know how much it has reached you, but this is a very difficult concept to make you understand. Both the angles are like this. In phase, both the waves are going together. There's no angle difference. There's no angle difference. Suppose if out of phase, what happens? The two waves are like constant phase difference. Yeah, constant phase difference. Okay. Out of phase means completely 180 degrees. Is that clear? Understood? So we are sometimes our mood goes off suddenly. Is it not? Out of phase. Yeah. Is it not? It has. So earlier what happened? There are few students who were here. You were out of phase, you were constant phase difference, you were in phase in the beginning. But now I don't know how many are in phase. Do you understand the concept now? Did you understand the concept of this one? Okay. Thank you so much.
Thank you. Thank you so much.
Yeah.